Alright, picking back up, this will be part 3 of section 1-2 in geometry, and we're back to postulates. If you remember, a postulate is a fact that is assumed to be true in geometry. It's not proven. Now this one has a title. It's a segment addition postulate, so it must be important if it has its own title here. You remember in the ones from section 1-1, it was just postulate 1-1, postulate 1-2. Well, this one's a segment addition postulate. And it starts off with saying if point B is between points A and C, then the length of AB plus the length of BC equals the length of AC. And it kind of makes sense because if you look at the drawing here, then if you add the little pieces together, well, they create that big long piece. So kind of remember the segment addition postulate as adding the parts to equal the whole. Add the two small pieces together to equal the big length. And right down here we have an example. Now when you work these problems, I highly suggest that if you don't have a diagram go along with them, go ahead and draw the diagram to go along with it. Notice that this one's set up the same way as the postulate itself is set up. So B is between A and C, and it says the length of AC is 14. So what I'm going to do is I'm just going to draw a bracket across the entire AC and mark that as 14. And BC, well, that's just this little piece here. That is 11.4. So what we're missing here is the length of AB. Well, these two small pieces add up to equal the big piece, so we could write an equation for it. We could call this x, and then we know we have to add the other piece to it to equal the whole. And we could solve that by subtracting the 11.4. And that's going to give us x equals 2.6. Or most of us are probably smart enough to figure out if the entire length's 14 and this uses up 11.4, you're just going to subtract to get the leftover. So I think we have one more example based off of this. So I flip the page over, and it says S is between B and T. So notice S is just somewhere in between. I guess that should be B, so I'm going to fix that real quick. Actually, this is probably the typo right here. It should be between R and T. Alright, so RS is 2x minus 7, and ST is 28, and the entire length is 4x. So if we think back to the segment addition postulate, then the two small pieces added together equal the big piece. So I'm going to say 2x minus 7, that's this first small piece here, plus the other small piece is 28, equals the big piece, which is 4x. Well, now it comes down to a little algebra work. So hopefully you realize that you got to get your x's on the same side. So most of you, I'm guessing, is going to subtract 2x from here. And that will add out. This, when I combine the negative 7 plus the 28, will give me 21. And then if I have 4 x's and I take away 2, that's going to give me 2x. So to finish solving, if I'm multiplying by 2, I have to divide by 2 to undo it. So those will cross out, leave you with just x. And 21 halves is 10.5. But notice, it didn't want to know what x is. It wants to know what the length of RT is. Well, the length of RT is the full length, which is 4x. Well, if x is 10.5, I'll have to multiply it by 4 to get the length of RT. So RT then would equal 42 for its length. Alright, we're going to go ahead and stop now and work a couple of problems. So I'm going to move this box real quick, And it looks like you have 6, 7, 14, and 15 off of page 17 at this time.